Okay, so last Wednesday we went through some in-class problem solving. Okay, good, we'll hang on to that. Let's try that sheet. And we're going to do those exercises a couple more times. The objective was not to go through the complete homework. The objective was to give everybody a chance to do pieces, to sort of learn how to learn. And so I assume everybody saw that that homework 8, that was a previously assigned homework, we're actually assigning that again. So you get to turn it again. If you've already done it, that's great. Your job is very easy. You just turn it in again. If you haven't had a chance to do it, then you have a lot more background. I had 3 students come to office hours yesterday. I think all 3 of them found it very useful. It was interesting to hear the variety of things that people were sort of struggling with. So I advise you to, if there are things that are blocking you now, and you know this somewhat because you may be struggling with some of the homework, we have office hours, or we can make arrangements with other times to meet. The videos, let's see, I just posted a video on the design part as well. I assume people still find the videos valuable? Yeah? Okay, good. That's good. Very glad. And how many people are using the IPython notebooks that we post? Looking at them. Okay, so how many people are having trouble with installing IPython notebook? Okay, so come to office hours. Yeah, get that solved because it's a very useful tool, and we can post materials in other ways to review what was done in class, but you also have the videos as well. Okay, so today I'm going to talk about testing. Let's see, how many of you have, let's see, I think the people here, how many have been programming in Python before? I think in the other class, show of hands was very small, like 1 or 2. Anybody? Okay, how many people, almost everybody here has done some programming in MATLAB before they took this class. Yeah? Okay, so 1 or so not. Those of you who have been programming in MATLAB, what kind of testing would you do for the codes that you would write? I assume you would basically just write a long script. Is probably what you do, or something interactively. How did you evaluate whether or not the result, the computation seemed to be correct or at least consistent? What would you do? Yes?
Well, I would test for the smaller sections of the code we're working. So for MATLAB, I would delete the semicolon at the end. So I wouldn't.
And so you would delete, I'm just going to repeat because of the recording. So you're saying is you would do it for small sections, you would delete the semicolon so that you would see the output for individual steps. And you'd see if that made sense to you.
Yeah, and then so for Python, do something similar, like just say print, whatever it is.
Okay, and so the idea is for Python, you could carry over that same technique. And that's a very useful way of doing sort of initial development. And I know with some of the students I spoke to yesterday, building things up in small sections, especially complex statements, like we were translating the statement from MATLAB that did estimated the parameters of the line, the slope, and the y-intercept. And that was sort of a long expression. I mean, you had to computing the product of the data matrix with its transpose, and then you take the pseudo inverse of that. They multiply that by the transpose of the data matrix, and so on. So taking apart that piece by piece, understanding how the data is structured. I mean, for example, one of the points of confusion was, when was something a list? When was it a matrix? What operations can you do on a list? Can you do on a matrix? These are sources of confusion and error. A lot of times the errors are really apparent because you try and run it and you get an error immediately. Sometimes you have to pull that shut. It doesn't close easily. Yeah, you just have to pull. Yeah, yeah. So that's good. So that's all for sort of this case of where you are doing the initial development. When we talk about software engineering, we're also talking about something running over a period of time. The extreme case is it's running in production like a Google web server, and there are literally millions or even billions of people who are using those codes. But the more common case in a science environment would be that you develop a code that other people in your team are using, and they may be using it in a slightly different way with slightly different data. And so you want to get some comfort that they won't encounter a problem. A really good example, sort of a motivating example for me, is someone I've been working with in the physiology department. And her research team does studies on memory. And they train monkeys, is the main objective way they evaluate this. And they do this using a visualization game. And she's responsible for developing this game, where the monkeys sit down and they get sort of banana rewards when they aim in the right direction. And so she's very concerned about the fact that when they train these monkeys, if she has a bug in her code and it doesn't work right, they aim in one direction and the monkey sees something different, not only is the experiment damaged, you may not even be able to use that monkey because now they've been trained the wrong way. And that's very costly and embarrassing. And so it's a very personal, emotional feeling. And I think that that's where people get really interested in testing, is when you sort of see this, this gut effect, like, oh God, I let people down. I didn't work right. It doesn't perform the way I thought it would. So testing, it definitely takes more time to include test code and to think about exceptions. It's very different from initial development, where what she just described is very reasonable. You print to see if it works for like that first pass. The problem is there are all the cases you didn't think about, which somehow you want to make sure you're covering. And there's also the problem that as you add in more code, you may be going through the code you've written in different ways, or you may have modified the code you've written and not done tests to check for that because it wasn't the initial development. So those are all the motivations behind it. And I can't stress enough how important testing is, and it's actually part of a larger view about how you build software, and that's this notion of test-driven development. So here's a little word chart about testing. So I gave you a bit of the why. The term exception has, in a computational concept, have anybody run into this, what an exception is? Okay, fine. So we'll go through that a little bit. It's an example about how testing is viewed as an activity that you run separately from the production code. Exceptions are trying to catch things that you didn't necessarily plan for. So one very simple example is I'm going to do a computation and I'm going to divide x by y. I didn't expect that y might be 0. So I just didn't think about that. Or another one is I open a file, but that file doesn't exist. So in the way you handle these things are a little bit different. So then the core testing is about this notion of unit tests. There are interactive tools for debugging that can be used. And then just sort of some overview. Okay. So why tests? You have to pull it real hard. All right. Okay. So if you remember, we went through the last design discussion was some detail about this interaction diagram, designing the these various components. So this shows the enzyme analyzer and the CSV reader, the CSV file reader, and then we looked at the details behind CSV file reader. And this is all sort of this design scenario where you're doing your initial development. Right, so now we've got what we did when we left off the class before last, which was about design, is we've gotten sort of the structure, how the components interact with one another. And I said at that time that this was not about developing the internals of how that component is actually implemented, which can be a lot more elaborate. So we saw that this CSV file reader, when you create that object, you give it a file name. And then you can read data, and that will update the column names and this data dictionary. And then you can get out what you want, the list of names it knows about, and then individual data. So when we implement the actual code itself, there's a lot there. There's a lot of detail there. And I'm going to go through this a little bit just so that we get a feeling for some of the detail involved. I think some of you have sort of poured through this a little bit anyway, because a certain amount of testing is a matter of appreciating some of the details and some of the struggles you go through. And we can do this a little bit interactively too. Okay, so I know the last time we did some stuff with IPython Notebook, there was some question about how you get it started. And so I'll do that again. So my IPython Notebook for this class, it's lecture 12. And so I'm going to start up IPython Notebook. in the same directory where that lecture 12 is. And with blinding electronic speed, I will eventually get a web browser with a tab. It shows me the notebook. So what it shows is it shows that notebook in that directory, and then if I click on this, I'm actually in the notebook, or I could have created a new one. All right. So here's that full class. And what I'm going to do is I'm not going to go through and try to redevelop that, because I think you've seen parts of this already. But what I do want to do is point out that there's a lot of detail here, and there's some challenges with trying to figure out what to debug. So let's take it apart piece by piece. So this is a class. The class gets constructed by calling this a init method. So I would say, would give the example down here. Here's an example of where I have created the class right here. So I've said CSV file reader, that's class name, and the argument is a, actually that's going to have to change because I changed this to 12. All right. And the argument is a file name. Okay, and then what I can do is once I get that object, I can use the methods, like I can read something and print something. So let me just run this, run that cell. Actually, you know what? Let me do this. Let me delete this so I don't. You can see it actually does something. Do that. Okay. All right, and then let me put it back, and now I'll print it. Okay. I think it's called data. That's what I want to do. Okay, so now we actually get something out. All right. Okay, so when I look at this method and I want to then think about how am I going to, I look at this class, because these are our components or classes, and now I want to test it. So that specification was done in terms of classes. Classes have attributes or instance variables, and then they have methods. Methods are functions that are specific to that class. And I'm asking a question, well, how do I go about testing it? And also, it's not just testing it. This notion of test-driven development is about how do I write tests and in companion develop the code. So to some degree, what test-driven development is about is it sort of turns testing on its head. Instead of doing testing as something that is an after the fact, after I've already implemented something, the idea is that since I've done this development somewhat top-down, I've specified the components and their methods, I can then write tests because I know what that class and its method should do. So, I mean, some of this is pretty easy. For example, let's take this out over here, and I'm going to do it. I'll do it like this, run that again, and then create a new line. Let's delete this. Actually, I'll just copy over it. Okay. So to some degree, what I'm saying is that even if I hadn't implemented this method, if I'd done something much, just use the sort of skeleton approach here, I could write these statements here. And maybe I wouldn't get anything out when I printed data, but I know what's called the interface. I know how to call it. When I call the constructor, I give a file name. And maybe all the constructor does in the skeleton implementation is print out what I called. But at least I know how to call it. So then when I'm doing the development of the method, then I still have something that runs it. And then presumably I can then also, based on how I'm, what it is I'm reading, then I can see whether or not I get a reasonable result. Okay, so the next challenge is, now some of these parts are pretty easy to test. For example, the constructor. It doesn't do a lot, right? Yeah, all the constructor does, I mean, basically, what would I know if I, it's pretty hard to get this wrong, especially after you're looking at it. But if I wanted to test that the constructor is running right, what might I do? What might I look at? Okay, so what does the constructor do? Yeah.
Just instantiates an object.
It instantiates an object, and in this particular constructor, what does it do to the attributes or instance variables?
Well, you pass in a file name, and it sets the file name of the variable in its field.
In its object. So the object that's constructed has this, and the way you reference a variable within the object is self dot. So it has this variable self.filename. So one thing that I could do down here is after I do the construction over here, let's just go like this, I could say print csv.filename. And I better get back this argument over here, because that's what I expect that constructor to do. So that's a feature of the constructor. Now that's interesting. It didn't work. And why didn't it work?
I think you forgot an E.
I did forget an E, right. So this goes to another very important point about testing. Actually, it wasn't intentional, by the way. That was accidental. But a very important point about testing is that when your tests don't work, it could be that your code is bad, or it could be that the test was bad. You don't know. Right. And this is one of the frustrations people often have with testing, is that you're sometimes, you are actually writing twice as much code. But it's worth it because of, I gave this example of my colleague who was doing the physiology experiments with the monkeys, and very costly to make mistakes there. So hopefully this time the test actually runs. Okay, so I got back what I would expect. So the point is that when you're looking at methods, you need a couple of things. You need to be able to know what the interface is to the method to be able to write the test, because you got to be able to call it. It's even a little more subtle than that. These methods also have dependencies. Yeah, just make sure you pull it close all the way. For example, I can't say if, well, let me show you here. Let's do it like this and like this. I'm going to rename this and call this CSV file 1 and this CSV file 1. Okay, so what's going to happen when I do this? Okay, so I'm creating a new object called CSV1, and it's going to be a CSV file reader object. And I've decided that I'm going to do this test on the constructor. I'm going to, first print this, and then I'm going to construct the object.
Well, first your object doesn't exist, so it won't
Yeah.
be able to print it.
Yeah, exactly. That's what's going to happen. Right. So this is a very trivial example, but it raises an important point, and that is that suppose I wanted to test, for example, okay, so now we got that. Let's do another one too. All right. So similarly, if I wanted to test CSV file read, I'd have the same problem, because that object doesn't exist yet. And it gets even more, more complex than that, is that the way this this particular method works is that also the access to data would be limited as well. Yeah, go ahead.
In MATLAB, does the exist function? Is Python everything similar? Or
You can test for existence of something, and that's something you certainly can do. I'm just saying that a lot of times what will happen is that there will be a certain kind of protocol you have to use to work with an object. For example, not only do you have to construct it, but you may have to read the data before the data are available. And so if you don't, when you want to test the method that says, give me the data, you better have read it first. And so you have to understand these interactions. This is part of testing, is understanding what those interactions are, so you get the protocols right. All right. Okay, so now the last point I wanted to make is when you have a method like this, which is pretty involved, and I say it's involved for a couple things, that the things that you're testing when you run a method, you're looking for things that are somehow going to cause you problems in situations you may not have necessarily thought of. So one example was the divide by zero. If I give you data that is somehow strange data or unexpected data, that will cause, you want to be able to test for that, sort of extreme cases. If, for example, the assumption is that the arguments are all, the denominator always has to be greater than zero, or at least non-zero within a certain interval, that's something you want to test for. What's something else that's important to think about when you're testing a method? Okay, and I'll give you a hint here, and that is, if you look at this method, the way things work here is, okay, so there's some initialization. Then there's this loop for all of the lines in the file. Okay, it's reading each individual line. Just basically, conceptually what has happened is you've got this list, which is a list of strings where each string is a line in the file. And then it's going through this for loop, and it's parsing it, looking for commas, and it's saying, well, is this the first line? The first line, what's special about the first line in a CSV file? Anybody? Okay, give you a hint. Comma separated variable. What do we have at the top of the comma separated variable file? We have a string, right? That's the name. Okay. What's most likely? So that name is what data type? Okay. Is it a float? Is it a bool? Is it a string? This is a sleepy day.
String.
Okay, it's a string. Thank you. Okay, it's a string. How about the columns? The values that we've all been using in our columns are data. What data types are those? Floats, exactly. So we want to treat that column name differently. First of all, it's a different data type. And secondly, we want to treat the name differently from the values. Okay, so that means that there's some exception logic. There's some logic here that has to sort of go different ways depending on whether it's the first line or a subsequent line. Okay, and what's the way you do something different in programming? You use an if, right? So that means that sometimes the way the code will work is I'll go here, and sometimes I'll go over here. I want to make sure I cover both paths. Now I should, right? Because if it's a CSV file, I should get that header and I should get the string. Sometimes it's not the case. Sometimes it's all data dependent. It may be that if I might have special logic for negative values, for example. So I have to make sure that I present my data with negative values. What about if I gave you a file with only the name? There's no data is empty. You know, would this method work? What would it return? What would it do? Would it work right? So these are kinds of things you want to think about when you're doing testing. Are you sort of considering all the extreme cases? Okay, all right. So let me go on to exceptions, and I'll get back to the slides in just a second. We can go through that a little bit, but I think just looking at code, I think, is a little bit more engaging. So the notion of an exception is this is something that happens when you're running your code, and for some reason, the computer cannot interpret the instruction that you want to execute. Now, I gave you one example already. Divide by 0, right? Okay, so here's some examples here. Probably should have cleared these out. Just run that again to clear this all up. Okay, so I have this very simple function in Python, divide. I'm going to divide x by y. And so if I say print my divide, 4.3 comma 2. Now that should run very easily. But then when I do 0, obviously I have problems. Okay. So there's a few things that I could do. I mean, I could check for numbers that are fairly small. That's one thought. The problem is a lot of times you will be at some level in your code, and you'll call maybe something from a package. And you don't really want to look through all the code in that package. It might be a linear algebra solver. It might be a matrix inversion program where they didn't worry about looking for non-singular matrices, or singular matrices rather. Whatever, and they end up with a zero determinant. I mean, there's a whole bunch of stuff you don't know what's happening underneath you. And somehow you need a way to protect for this. You don't want the thing just to blow up. And the way that happens is something called an exception. And MATLAB has this concept too, and that is that it's in this kind of structure here. You're telling the computer, I'm going to try something. I'm going to try and divide x by y, and if that doesn't work for some reason, there's a problem there. Then I'm going to do something else. In this case, I'm going to just to say that the result is none. All right, and so if we do it now, we can say print. Let me run it too. Okay, and I'm just going to do a new cell here. So I can say print. Now this. I better. Yeah, I think I just ran it, so I've got a new one. Okay, so print my divide, and I'm going to do. The problem before was 0, so let's do 3.0 comma 0, and so then if I run this, I get a result of none. Okay, so this is nice because there's a whole bunch of things that could be wrong underneath. I mean the other thing is that's a divide by 0. I mean, what about let's make it even more extreme. How about if it's 0 by 0? What happens then? Well, once again, it's the same result because, again, that's not going to work very well. Now, there are a lot of different kinds of exceptions. Some of them are, sort of like programming that you didn't think about all the possibilities. So one possibility is that I didn't think about dividing by 0. There shouldn't be zeros in my data. I'm looking at concentrations of a substrate. Nobody should give me a 0 that, well, there was a typo when someone entered something, happens like that. And there are different things you might want to do for that. Sometimes it's your bug. Sometimes it's a matter of somebody else did something that really, they didn't understand what's going on, or maybe you just didn't understand what was happening. So depending on what the situation is, you're going to want to do different things. So here's another example of an exception that occurs. Someone gives you a file name to open. So you're going to run like the enzyme analysis use case. And someone has to give you an external file with CSV format with one column is reaction rate and one column is substrate level. Well, they gave you the wrong file name. Okay, and they're running this program at the command line, but they didn't do it in the directory where that file is, so it wasn't found. Okay, that's actually not your bug. I mean, that's something that you want to inform them that this file wasn't found. It's not a bug in the code. It's a matter of they need to run it in the right environment. So what you'd want to do there is a little bit different. You wouldn't want to give them an error. You'd want to give them some sort of informative message. So that's why this try except kind of concept is very useful. Now, you can actually get a lot more information from an exception if you so choose. Exceptions, you can actually have an object. There's an object that gets generated when you have an exception. And so, for example, this e.message over here, if you say except, and the exception is a kind of class, just like enzyme analysis, like the CSV file reader class, and that this is the object that gets constructed. And it's the sort of the syntax here. And then this object has attributes associated with it, so that if, tell you what, why don't I, for this purpose, let's try. I'm going to just copy this code out here. We're going to do this in line instead. Okay, and let's see, try except, it better be at the same indentation level. All right, and I'm going to put in just numbers here. Let's try 3.0 divided by 0. Okay, and then when I run this cell, okay, so what happened here is I ran this cell. It tried to do 3 divided by 0. That was an exception. So that exception, when it enters this block over here, it then creates an object called E. And now I have the opportunity to look inside of E. And let's take a look at what E has. So E is an object. An object you can investigate in Python. Oops, I didn't mean to do that. I meant to do this. So one of the ways you can investigate an object is there's a command. Well, if you do help E, it will tell you the kinds of things you can look at in E. So help on. So this is the object E is an object of the class 0 division error. Okay, and here are the things that you can look at. The underscore things are all internal methods. Here are the kinds of things that it will let you look at. It will let you look at the message and then the arguments. So we looked at the message over here. That's what we printed out. What happens if we look at the args, e.args, and take a look at that? Okay. And so that's the other information you get there. In general, that's very useful if you break things apart like that, and if you get an error and you can isolate it and you can then see what kind of exception is there. That's very helpful. Okay, let's do one more. So I mentioned the problem with file names. That file name, you can potentially have a file name that is invalid. So, for example, I actually changed this file name. I changed it from 11 underscore to 12 underscore. So when I run this same code again, I'm going to have a problem. Okay? So I got this error here. So this is a different kind of exception. This exception is an I/O error exception. So let's see if we can try and fix this so that instead of getting an error, we now get an exception and hopefully a message. All right, so if I want to make it so that we get an exception, do you remember the first thing I have to do? A try, okay. All right, so this is going to create a new block, just like a for block or an if block, it's a new block, which means what about indentation? I have to indent all the lines here. So I'm going to indent by another 2. Okay, all right, so that's the end of my try block. Now what do I need to do?
Exception block.
Okay, all right, fine. What do I want to do in the exception block?
Usually what you want to do is you want to print something like a stack trace. You want to basically give them a message that says, hey, this.
Okay, so there's a problem here. Okay, so let's see here. So we probably want to look at the syntax for except. So if I said, well, okay, so this is a class of exception over here. This, let's say just accept exception. So that'll be the class we'll do as E. And how about, let's for just starters, what might we do with E? Or what would you like to have happen here? Let me ask that.
I like giving them a message, e.message, and just printing that out.
Well, we could do that. We could do that, but I think there's actually something more important here, and what that is that in this context, we know that this is actually a user problem. They give us a file name that doesn't exist. So how about we say print something like file %s not found. Do you know what I'm going to have to do next to do that? This formatted print? Okay, so print, yeah, so S, we have to match it up with a variable. What's that variable we're going to use? File name, exactly. Very good. Okay, so now let's see what happens. Let's see here. Okay, so it's right here is the answer. That's the output. So that's exactly what we wanted. And that's a lot more descriptive than having something that just says I/O error, where somebody has no idea what is going on. Is that clear what happened over here? Let's let me create some more blank lines so that it's clear what actually happened here. So what we did is let's see. Let's change this to 12 because this is the one that actually should work. Okay, that works. So now let's change this back to 11. And if we run it now, it's not found. That makes sense what happened there? Okay, good. All right, so that's exceptions. Very useful tool to use in your code. This is very important for something you're going to run repeatedly over a period of time. And that's really, I think, sort of the distinction between the experiences that many of you have had. Many of you have had the experience of running code really for your own purposes, like a class project or some laboratory data. You may or may not have really shared that with anyone else. But if you're going to share with someone else, then they're going to do it differently. And you want to have it detect these kinds of conditions. Okay. So let me switch back to the slides for a second here, and let's see here, over here. Okay, all right, that's CSV file reader. We went through the details, talked about a lot of challenges, easy to forget stuff. Make sure you get all the required cases, okay. I've talked about, the problem with implicit assumptions, what happens if the file doesn't exist, and we saw a few cases of that. Okay, all right, so the lecture is on testing, and so I gave you sort of the motivation behind it, some examples. Exceptions are not usually taught as part of testing, but it's another element of this whole issue about dealing with things that are unexpected in your code and looking for that. In general, when people talk about testing, there are a few different kinds of testing you'll hear about. So I'm assuming for right now that you've organized your code into components. We've been teaching about object-oriented components where you have classes, and so that's the sort of natural componentization. But it could also be that it's organized into functions. And that's another way of organizing code as well. It's just individual functions. A unit test is something that tests a small piece. So typically a function, when you think about when you're doing tests of a class, you're probably doing tests on individual methods in the class. So like we tested the read method, and retested the init method for the constructor. So the type of thing, this unit test, the idea is it's something relatively simple that hopefully, amazingly noisy, isn't it? Really annoying. The unit test is something that should go through what's called all the code paths, all the coverage in the paths. Remember, we had some ifs in the CSV file reader read method. So we would want to make sure that whatever we're doing, goes across all those ifs, because what's one of the most common problems you're going to have in MATLAB and in Python when you're running a piece of code? Typos, right? Because it's not that you don't necessarily know until you run the code and hit that statement. You don't know whether or not you've actually written something that's executable. Yeah, I can type in anywhere in MATLAB or in Python, dummy, or don't run, and it doesn't care as long as it's the right syntax. It's indented the right way. It will not care. It will only care about when it gets to actually executing that statement. They'll suddenly realize, I have no idea what the statement "don't run" does, and then it'll complain. So that's why this notion of coverage, of making sure you run through all the code paths, is so important, because typos are so easy. And they're so easy to make. And that's this notion of coverage. What fraction of the code actually gets executed by your test? Now, the other concept is something called a system test. This is something where you integrate more systematically the pieces together. You're running on something that is more meaningful. It may be that it's actually data from your lab. It could be a case where somebody had run into problems in the past, and that's usually a much more extensive test. Typically, unit tests run very fast, and system tests may take a lot longer. For production systems, there's another kind of testing that's often used, what's called continuous testing. It will use a mix of different kinds of tests, like unit tests and system tests. It's usually a wrapper on top. And by continuous, what that means is you have a group of software engineers who are making changes to a code base, and in the background, you're constantly running the test just to make sure that there's no problem present, because it's so much easier to find a bug close to when it's introduced than it is if it's been in your code base for a long time. It's just very, very hard to figure it out. So the principle behind test-driven development is that we actually write the test before we implement the method. We probably want to have the skeletal implementation to make sure you got the pieces right to implement the use cases. But you write the test first, and it's not hard to do because you've already defined the interface. And then that's the reason why it's possible, because you've actually designed things. And the reason why you do this is it gives you a very systematic approach to doing code development. Because once you've got all the pieces, the components defined, and you're pretty sure that they're the right components because the use cases are implemented right, you can see that you get the right use cases, then you can have a whole group of people go off and implement individual methods, and they can operate independently because they understand how everything interacts. And it's the other way that it works is, even if you don't have a group, just for you individually, I think what you'll find once you leave school and you're in a working environment, that your time is very fragmented. You have a lot of meetings, a lot of people are bothering you with things all the time, there'll be personal things, all sorts of stuff come up. And you'll find that, well, gee, I can no longer spend a day working on a programming problem. I maybe have 20 minutes. What can I do in 20 minutes? Okay, and if you've defined this overall structure, and where you now know the individual pieces, you can actually make productive use of 20 minutes. And that's one of the other elements of being in a software engineering environment, is you've got to be able to do that, because you're not going to have that day to work on something uninterrupted. All right, so exception handling, we talked about exceptions, what they are, different kinds of exceptions that you can get, how to structure it with the try and except blocks. All right, so let's get on to unit tests. So one of the questions is, how do we, what is it that we have to test? So let's just take one class, the CSV file reader class, and here are the methods in the class. We know we're testing methods, so that's fine. So we've got 4 methods here. what do we know right away about the order in which, when we run one of these tests, which method do we probably want to test first? Yes.
The initialization.
Right. You want to test the underscore init, the constructor. Why is it important? Someone else. Why is it important to test that one first? You don't get the answer. Why is it important to test that method first? Okay. Do you have an object before you construct it? You don't. You've got to do that first. Remember, I tried to do the print csv1.data before I said csv1 equals csv file reader, with the initialization. I don't have an object yet. It doesn't exist. So I can't do it. So I clearly have to do that first. Okay. Well, okay. So fine. I'm going to do this one first. Now, which one do I have to do? What do I have to do second? Can I do any of them second? Suppose I just say, okay, so I've done this. Now I'm going to look at the column data. Now you're banned for a minute or two. Why can't I do column data? Go ahead.
Because you have to read the file.
I have to read the file. I don't have any data there yet. So how could I get it? Now, this depends a little bit on the implementation. I've seen some of you, when you've come into office hours, and your implementations are a little bit different. That's fine. We're just describing an interface. Some people will actually read the file in getColumnData or in getColumnNames. If you did it that way, then you possibly would have a different ordering. But if you read all the data like I showed you with that implementation, then you certainly have to do this one second. Okay, which one of these do I have to do next? Doesn't matter. Why doesn't it matter? I already have the data. I have all the information. So this is something when you sort of think about how you're going to do your test, this is the kind of thing that you have to work through. There are these interactions between the data and the methods. And anything that gets assigned, a value that's assigned, like the CSV file name, okay, if something's going to reference that, like read, then clearly this has to precede this. And similarly over here, these two are assigned, the columns and the data are assigned in read. So these things that reference it, actually column data, that's interesting. That's, okay, let me just fix that for a second because that is wrong. This, obviously, goes over here. All right. Okay, so anytime there's that kind of relationship, that dependency, it tells you what the order is. Okay. All right. So let's talk about tests then. We've done a little bit of this already. So if we want to test for the constructor, so at this point, all I know is I've got this interface. I've got this class called CSV file reader. It's got a constructor with how many arguments? 1. And what's that argument? File name. Okay, so I know I'm going to have to come up with a file name. I know that this is the format for the construction. Okay, so now I've done the construction. So now I'm writing tests. I'm not just interacting in the console or in IPython notebook. I'm writing tests. So what is it? What's the code I need to write to check to see if this thing works right? We've seen what the code looks like in the in the constructor. It's really simple. We're assigning an internal file name. So kind of thing that I might do is I want to make sure that, well, whatever the file name is, I want to make sure that it's the right file name, and that so here's basically a bunch of tests here to try and determine whether or not I did the right thing. So if it's not the same as what I put in, or if it's a 0 length, or okay, so that's interesting. Okay, actually, you know what? Okay, so the intent of this if here is to see when something is wrong. Okay, so clearly I want to make sure that the file name is what I put in. How about these two statements right here? Are those wrong? I mean, would I have, is it wrong to have 0 length name after you get finished in the constructor? No, that's what you would expect. So actually, this test is not correct as it stands. Again, another example of where I didn't intend to make a mistake, but it's so what probably would I like to have here? Not equal, right.
And would you also want to have ors instead of
Yeah, exactly. Very good. Right. Okay. So I think with Python, I think this is the not. Yeah, I think that's it. And I think or is 2. I always have to look this up. I think or is 2. Isn't it? Is it exclamation?
Yeah. Oh well, for the not equal.
Yeah.
Yeah, just exclamation.
Oh, the exclamation. Oh, it is. Okay. Sometimes both will work. Okay. Good. All right. All right. And then this over here also has to be an or. All right. Okay. So actually, you know what? Let's do just to make sure we get this right. We've got this code here. Let's go back to the IPython notebook and just make sure then that this looks reasonable. All right, here. Okay, so let's copy the code over. All right, so we've got the object we're going to construct. We've got the file name. Okay, and then let's see what happens when we run it. Invalid syntax, so that is apparently not the or syntax. Let's see if this is it, and if that's not it, I'll look it up. Okay, yeah, that doesn't like that. Okay, nobody knows right now. Okay, I always have to look. Do you remember what it is?
I believe it's just or.
Is it just or? Okay.
I think so.
Okay, well, let's try that. Yeah, I mean, this is a great example, and actually, you know, I'm not embarrassed. Oh, you know, that's good. You know, so we got some feedback right away. See how that turned red? Yeah, so it's a keyword. It's a reserved word, so that probably is right. And you try the logical. You try something that makes sense, and no, okay, all right. No, that's very reasonable. Let's see, or in Python. Built-in types, basic operations, and or in Python. That looks good. Okay, what do they say? Just go down to the answer. Okay, it's not. That's not for. Okay, probably Boolean operations, maybe. Disjunction. That's a good one. Yeah. Yeah. Okay. Control flow logical operator examples. That sounds encouraging. Okay, and or. Huh. All right. I think the problem is something else because I think or is right. You know what you can do here is let's try if we do something like this: true or false, and then run that. You see? Okay, so that's not the problem. Our problem is something else. What do you think it is?
It could also be the not equals. Because there's the keyword not.
You know what? There is the keyword not. And the other thing is we can see that, let's say 1, let's try this. I think this is another possibility. Let's see, 1 equals 2. 1. There are a few forms to this. There's also, let's try this. Make sure that's okay. Yeah, okay, so that's not it. Okay, so that looks good. Like,
yeah, what is attribute? What would that mean?
okay, CSV file. Okay, that's good. That's good. Yeah, that's where. Okay, I didn't read all the way down. Yes, so CSV file.names. Yes. Okay, so good reading. This was a good exercise. I really like this because you're getting. See, the problem is when again, I'm not patting myself on the back for making mistakes, but the problem is it can be very easy to sit here and see things just laid out that work out right, and you don't know how much trial and error I went through to get there. And it's really good to give you insight that, yeah, everybody has to do this. And then and one of the important things was you just pointed out was read the error message. It's very easy to pass over that. Okay, so we don't have this attribute names. So let's look back at the code. Our code is somewhere up here. Okay. So yeah, we don't. We have something called columns. Okay. So that's our problem. All right. So if we go down here, so what we're looking for is not names. We want columns. And then data. I think data. Well, let's just try it. Yeah. Okay. Looks good to me. All right. Now. Okay, so that's fine. Now, this file does not actually exist, right? But that's okay, because we're only in the constructor. That's not going to be a problem until later on when we do which method? Read, exactly. Okay, because I could put anything in here. I could put in XXX. It doesn't matter. Okay, but what would be a problem is if that method didn't work right, if it didn't actually do the assignment. So if I, for example, reran the method, it's way back up here, and I said, suppose I just comment this out, and then I run this. And now I go back to my test. Down here somewhere, unit test. And now I run it. Okay. Right. Well, no, it's the same type of error, but with a different instance variable. And has no attribute file name because why doesn't it? Because I commented it out. Exactly. So I mean that's an example of the kind of thing. This is what you want to do in a unit test. That capability. The problem is that what I've shown you here, going down here, and we just see this with all the stuff we wrote down here. Blah blah blah. Right here. Okay. Well, we can write it again at least so we get the answer. I gotta go right here. Answer. Right. What does it say? Oh, I didn't run the method apparently. Okay. We can go down here, and now it should run right. It still says what does it say? Files has no absolute. Oh, did I? Oh, somehow I reverted to has no absolute. I don't know what. I must be I must have two instances of this. That's the only thing I can think of because I fixed that before. Okay, all right. So fine, we've got this one test built for CSV file reader. That was, do we have to go to all this trouble? I mean, this seems like we're going to repeatedly be doing a lot of this stuff. So that's where some different kinds of techniques are potentially very useful. And going back over here. All right. So there's a notion of what's called a test framework. So that a lot of the overhead of doing testing is taken care of for us. Because just for that one test for the constructor, we have to actually write a lot of code. And we can simplify our lives a great deal. So just like we were using the NumPy package, there's a package for testing. And there are actually many packages for testing. I'm going to use one particular package called unittest. And it's going to give us a lot of facilities that are sort of nice. And the way you use this is, obviously you have to do the import of the unit test. Tests are typically done in a separate file, so you have to also import the class that you're using, so the CSV file reader. This is just saying this is a name I'm going to use to run the test. And then the way the test is constructed is there's actually a new class, a special class that you construct, that you define, called test, and then with the class name. So I'm testing all the methods in CSV file reader, and it inherits from this unit test something called test case. So that's just sort of the structure that work with. That's the framework. This is the class under test, and what it is that's being tested. Okay. Okay. So then, if we look inside this test method, this test class, the structure of it is that you have individual methods. They're going to do specific unit tests, and typically you're testing one method in the target class. So the target class here is CSV file reader. And then I have methods in this test class, test CSV file reader, that are of the form test something. So like here I'm testing the constructor. So now instead of writing all that other code, what's going to happen is I'm going to run the thing that I'm testing, in this case CSV file reader. I'm going to construct something. I put it into an instance variable. I didn't actually have to. And then we've got this special method that we inherited called assert true. And basically what it does is you give it as an argument something that's a Boolean. So I'm saying that the file name should be equal, that this CSV file name should be equal to what I used in the constructor, just like we were doing before. And if it is, if it is, fine. If it's not, it'll say wrong file name. And then I can look also at, well, names. I don't want to use them. I think I'm using column names now, but okay, change that. So column names. At any rate, column. Oops. Well, tell you what. Let me just switch over to this, and we will do it here. Okay, because I think. Oh, okay. You know, that's interesting. Actually, let me go back and we'll copy and we'll create a new section. All right. Let's just have. Oh. Okay, here. Okay. Create a new section here. We will add on down here. We'll call it testing. Testing. And this will be a new heading, and let's just copy our code in over here. Okay, so here's our new class that we're defining. I don't have to do this because it's not in the file. We'll show you what that looks like in a file in just a second. Let's make sure that this will actually, oh, I have to import, unit test. Spell it right. Okay, make sure that all works. That looks good. Okay. Okay, so now I can do, I can potentially do this test, is the idea. Now, it actually doesn't work very well in the IPython environment. And the reason for that is that unit test, this class here, wants to have control. It has to know all the things that it's going to run. So even though I've set things up here, I can't actually run it quite like this. You have to run it as separate files. And let me show you then how we make that transition to separate files. So we go over here. And here is, down here, is the file that I'm testing. So what I've done is I've taken the code out of IPython, put it in a separate file. I have this file called CSV_file_reader. It has this class CSV file reader, and it has, you know, the methods that we talked about. We've got init, we've got read, yeah, those are the two that I show here. Okay, here is a separate file called test_CSV file reader. And what it does is it has some imports from unit test. It has to import this file over here because it's going to actually use CSV file reader. And then the thing that we care about over here is this test constructor. So you see the imports from unit test here, and then we're going to run this section over here, and it's checking to see if various things hold true. So we saw making sure that the file name is correct, making sure, let's see, I'm going to expand this a little bit so we can see the whole thing. All these are okay there. Okay, making sure the file name is correct, making sure that okay, so I think, and I may have changed things here, which may be part of the problem. Yeah, I called it names over here, so I apologize for that. I did change my names, but just to leave it consistent, I won't change it right now. And it's checking to make sure there is something called names that's defined, and there is this data that is there, but it doesn't have any values assigned. And that's all part of what goes on here in that init method. That makes sense so far? Okay. What's important here in CSV file test is this part down here is that if you're invoking this as a main program, which we will in just a second, then it calls this function here in unit test called main. Unit test knows to run all the methods in test CSV file reader that begin with test. It actually also runs, you know, anything with a setup first, and there's something with a teardown. So setup allows you to do initialization, and teardown allows you to do stuff later on. So let's do this as an. Let's actually do this. That's not what I wanted. We could create a different one. That's good. It's in the right directory. Okay, and get rid of this. All right. So what I'm going to do, let me overlay this one a little bit. Okay, so just to get a feeling for the flow here, let me start by just doing some prints. I think this will work. Setup. And then over here I'm going to do another print, test constructor. Okay, save both of those. And now if I say Python HON. Test. Okay. Okay. It says I have an indentation problem. Self. Yeah, it is, but it doesn't look to me like. There it is, right there. Let me see if did I not save this right? It should save. Doesn't look to me like there's. Thanks. Yeah, every time, right? Okay. Doesn't look to me like I have an indentation problem. I can try it one more time. Maybe it was a save. And it's still complaining. Okay, I don't know why it thinks I have an indentation problem. File name, it doesn't. Anybody else have any ideas there? I don't see why that's an indentation problem. Yeah, line 12. Okay, let's try it like this. Unindent does not match any outer indentation level.
Maybe everything after print has to be indented once.
Yeah, let's see if it complains about this too. Maybe because I added those prints in. Okay, see if that's a problem. Yeah, I guess that's it. I guess it just doesn't work in that context. So another example of what could happen: you make something you think should work, and it doesn't. And this is another reason why continuous testing is so important. It's much easier to find bugs close to when they're introduced. So these were bugs that I introduced just when I was, code that I knew was working before. And it's much easier for me to figure that out just by going back. All right, so we run it and we see. So the output is sort of interesting. The dot indicates the test that's running. So I have one test, one dot, and it even says down here, one test run. Okay, and so then that allows me, so what's happened here is I have a much more compact set of code. It's organized nicely because I have this, it's done by a particular method. All right, so let's start down here and see what we could do with doing a test for read. Okay, so def, okay, so what are we going to call, if we're going to test read, what should we call that? Yeah, that sounds like a plan to me, test read. All right, so in general, it's very nice to have code that's very boring. Okay, if it always follows the same pattern, I know what it is that it's doing. Remember years ago being a software engineer at a company where somebody thought it was very clever to write code with the variable names with the 7 dwarfs. Very clever. I had no idea what they were talking about. So, maybe if there was a Rosetta Stone somewhere that mapped that into OS data structures, I could have figured it out, but it was challenging. So yeah, and that's one of the things that's nice here. Now these are all instance methods, so what do I have to put in as the argument? Self. Okay. All right. So what are we going to do here? Okay, so one of the things that happens here, which I didn't show you explicitly, is setup always gets run first for each test. So the flow is, before you run a test, run setup. Before you run a test, run setup. So I actually already have in an instance variable this name here. Now I can start, for right now, we can just call it CSV, and we can do a constructor, CS. And actually, this is sort of nice, the way it works that. Okay, I think I just do that. And I can say, file name. Yeah, it does that too, which is sort of nice. That's a completion. I can do that. It's actually not necessary because I could have said I could have just used self.csv. We'll do that in a second. Okay, so what am I going to do now? Okay, so now I've got a CSV object. Now what do I do?
Self.search.
Self.search. Oh, okay, so any thoughts about what I want to do next? I have to actually run something here. Okay, so I have to run the method. So I've got to run. I'm testing read, so it would be a good idea to run read. All right, now so that runs the method, and okay, so let's just stop here for a second. And this is what I mean by test-driven development. Okay, so at this point, you could have started by writing this file. After the design, you could start writing this file. In fact, you could even do the constructor test before you implemented the constructor method itself, the dot underscore init double, double underscore init double underscore. Because you know what it is that it should do. And then when you write it, if you test the method by running this file, that would be great. So, at this point, I could actually even run this right now. Let's see what happens. Okay. Well, what error did I get? What happened there? Any thoughts? All right, let me see. I'm not sure this is all visible. Okay.
Maybe it's because you didn't finish the method.
Well, maybe, but let's take a look. Let's look at the message for just a second. So this is raises system exit. Let's see here. So it's in read, line 36. So the first thing you do is you go down here. I actually have implemented read, line 36. Okay. So look at what happened here. Where did I exit here? You see, there's actually something else that's coming out over here that we didn't see. See, look at this right here. This is actually coming from the read method. It's a long thing to parse, but that's common with messages. What it's saying is this file doesn't exist. Right. And the reason why that file doesn't exist is because I changed the name. So I'm using 11 underscore. It should be 12. I changed the name. Okay. Now, and the message, this is very common, and one of the things that's so easy to do is you will get a long string of printed statements, which is an error message, and it's very easy not to look at that because it looks so long and involved. But there's so much of the time that your answer is within that. So our starting point was just to find where it was that there was an error. So it was on line 36. And when we look in the code on line 36, what do we find? We find we're in the except block of a try except statement. It's something that we actually programmed for in this particular method. Okay. All right, so let's try it again. Oh, having stuff off the screen a lot of times helps. Okay, life is better. Okay, so a couple things you notice. 2 dots. Why do we have 2 dots? We ran 2 tests. Okay. So you can see what's happening here is we've got a very sort of modular incremental approach now to implementation. We can write our tests first, and then we can then we can do the implementation, do it a piece at a time. Okay. Let's see where we are. Okay. Okay, so the essentials of unit tests, this is sort of like my unit test survivals guide. You're going to have to import it. Then you import the class. X is the name of the class you're testing, wherever you're getting that from. And then the in the test file, the name of the class that you're using for testing X is test X, and it imports from unit test. And then you're going to have your various methods to run it. And at the end of this file, you have to have unittest.main, because that's going to actually call it so you run it. Okay, so I mentioned this notion of coverage and the need for high coverage because Python does not interpret things until you actually run it. How many? Let's see. There's something called the Python debugger that allows you to do stepping through codes when you encounter errors. Got a few minutes. Let me go through that because that's a very useful thing. Let's go back over here to, I have to get out of this and go back. The Python debugger actually works in IPython, and of course it'll work if you execute from the command line as well. And it gives you a number of capabilities which are very nice. So I'm going to go back. Let me just pick some block of code. Actually, you know what? I'm going to take this block of code here. And let's see here. Instead of calling this testing, I'm going to call this, oh, you know what? I think did I already have, yes, I already have a section here on Python debugger. Okay, excellent. All right. So the Python debugger, you get that. It's another package. So you say import PDB for Python debugger. Okay, that's where you get it. So we have an example over here, which is going to be, I will tell you right away, this is going to be problematic for many reasons. That's good. Okay, so if we run, let's see here, let me, all right, so I can run this and it will probably give me maybe even a new set of errors. Okay, that's fine. Where it is, I put that in there. Here it is, right here. All right, so, okay. This code has a number of issues with it. We'll get back to that in a second, and some of which we've already seen. For example, we know this is wrong here, right? That should be columns, not names. So we know we've got some bugs in here. Also, these tests we know are wrong. I mean, these should be ORs. You know, there's a whole bunch of things that are wrong here. So that's okay. What we've done here is what the Python debugger does. So we inserted a statement here, pdb.setTrace. So what does that mean? Why pdb.setTrace? Well, we imported pdb. That's the name, the main name. And within that, there's a function called set_trace. And that's really the one thing that you will be using. And what that does is when you execute this code, it gets to that statement and then stops. So that's what you see down here. It says Python setTrace, stop execution, give control to the debugger. So right here, you see something where now you have an ability to enter in commands. Just like you're typing interactively at a console. So one of the first things I'd like to know is, well, I've got this local variable CSV. What is CSV? So I can say print CSV, and I can run that. I think I can just hit enter. And so at that point, it gives me, okay, that's interesting. Well, it give me nothing. CSV file name. Okay, actually, let's take a look at CSV. Okay, so I'm not sure. I mean, it may be that CSV doesn't have a printable form. So you can look. You can inspect objects. So, for example, dir CSV allows me to inspect it, and I see that CSV has some attributes: columns, data, and file name. Okay, and I also know that I would expect at this point, since I have done the constructor, I would expect that file name. The file name attribute of CSV would be what? What should that be? What was my constructor? Should be 11_th dpa.csv. That should be that string, right? Because I'm inspecting the object. Right. So now, so those are the things you could do. You can actually also assign values if you want to. Sometimes that's useful. Mostly, I think what you'll be doing is just inspecting values like this. If you type in C, it will continue execution. Okay, and okay, so now it would be just as if we ran it without having this debugger statement in there. And it's complaining about this, our names. Okay, so we can fix that. We can say columns instead. And we can say or over here, which we should. And we can say if this is not equal. Okay, and then just run this again. All right. Okay, so now let's see, where are we over here? Yeah, that ran to completion. Okay, so now if we run this. Okay, so once again, we come to this one statement, and we may not want to come back here again because that may not be where we care about right now. But if we then do continue and just go to the end, we see that now we fix the problems. So we can inspect things, we can stop execution. I mean, typically what I do when I'm using the debugger, if I'm trying to figure out what's wrong, you know, once I fixed one problem, I would then move it down to something else. Say, okay, well, I fixed this problem over here. I know it's there. So I usually put it in front of wherever it is. It looks like there's going to be a problem. And then maybe I'd say, well, gee, you know, I want to then know what's going to happen down here, so I might run it again. Okay, so now I'm in the debugger. And now I can then do things like print CSV dot, let's say, data. Okay. Oh, okay. Why is CSV not defined there?
Because it's
Why is CSV not defined there? That's interesting. Okay, we assigned it up here. It should have stopped. See, this is local within that. Yeah, why isn't CSV defined? That file name should be defined. That's interesting. So this shouldn't work either, right? Yeah. I don't know why CSV isn't defined. I can't answer that. I mean, that's an interesting question. That would take a little more investigation. But these are the kinds of things that do occur, and sometimes you have to sort of sort them out. Yeah, I mean, it should be. I mean, sometimes it's a scoping thing. File name is not defined either. That's interesting. There's something strange that happened here because I haven't exited that block yet. If I just say continue, and then down here, then actually even open up another window, a cell. CSV should still exist. So I don't know why it behaved like that. Oops. Yeah, I don't know why it behaved like that. Oh, I've got to run it. Yeah. See, I don't understand that because after I exit that block, CSV exists. So the other rule here, and this is very frustrating, is although the intuitive thing should work, it doesn't always work. And the reason why it doesn't always work isn't necessarily always clear. So the answer is don't get stuck on it. Try things that look reasonable, and when it doesn't work, try something else. Because a lot of times the reason why something doesn't work the way you would think it would be is for reasons that you don't understand, and you don't want to get stuck on it. So it's not like, trying to figure out, why a transcription factor binds to, a particular part of DNA, where there probably is an underlying chemical reason for that, having to do with complex bonding kinds of conditions. It's not a science problem. It's a human problem of, how complex pieces fit together that humans have engineered. Try something else. All right. And again, that was not, although it was not an intentional exercise on my part, but I think it was useful to point out that everybody has these challenges. All right, so what we didn't discuss, I don't know if anybody's heard the term mocks, other than, in a sort of a hostile kind of interaction. Okay, so mocks are very useful kind of tools for when you're testing complex software. A lot of times you'll have pieces like entire websites that are needed in order to complete the test. And a mock allows you essentially to mimic or simulate something like that. Very effective for large systems. Performance testing, what we've been talking about right now is correctness testing. Performance testing a lot of times will become problematic as you work with bigger and bigger data sets. And understanding where performance problems exist is actually a challenge. There's profiling tools in both Python and MATLAB that you can use as if you get more involved with this kind of work, you will probably like to use them. They're very effective. Okay, so the homework is really to focus on this notion of using the unit test environment. So we've got this one class, CSV file reader. We looked at really primarily the method for just the constructor. So, finish the set of tests. We've got, 3 other methods there. And do that. And it's really much more about just understanding, how you put the files together and how they work. How many people have looked at the shared code repo? Okay, you will find these files that I showed you today in the Sublime editor are in shared code, that repo for 12. Okay, so look there, you will have it available to you, and then just extend it from there. And I think, once there's a lot of learning that goes on with hands-on keyboard. There's a certain amount of learning you get because you get to see me make mistakes, which is good. I think that's great. But your hands on the keyboard make a difference. This should not be a big effort. The main thing will just be the conceptual thing about putting all the pieces together. Okay, great. Have a good weekend. Just give me 1 second. I just want to stop the recording. Let's see if I remember.
Yeah, I thought I was picking up. I know I'm picking up. I counted down. I invited a bunch of people.
All right, and